In the last video, we created the mirror modifier. In this video, we will recreate the array modifier. This is part 2 of a series in which we recreate the modifiers into node groups. Let's add an array modifier. We will use this modifier as a reference as we make our GN array. So let's pin it so that we can see it all the time. Let's duplicate the cube so that we can use the same geometry for both the built-in array modifier and the GN node we are going to make. Open a geometry node editor. Now let's cut the properties panel into two so that on one we can view the geometry nodes modifier. Create a new node group and rename it to GN array. Let's start by making the count input. Add an input value and change it to an integer. The array has the minimum count of 1. Rename the value count and we are good to go. An array repeats, making a copy and transforming the input geometry. So first of all, add a repeat zone, connect the count to the iteration socket and the output geometry to the group output. Let's convert the input geometry to an instance using the geometry to instance node, and then let's put all the transformations inside the repeat zone. That is to translate, rotate or scale the instances. Only for now we need to skip the scale instance node with the switch node because I have seen it cause some issues if just pressed in line but not being used. Okay, now let's make the relative offset option. Add an input socket and set the type to boolean and rename it to relative offset. Add another input socket and change its data type to vector and rename it to factor. Connect a switch node to the factor and connect the switch option to the relative offset socket we made. If we now change the count, we will see a cube with different translation is displayed for each iteration. So now to combine all the instances formed in each iteration, let's use the join geometry node and connect it to the new output, which we then again connect to the join geometry. If we view the second output geometry from the repeat zone, we see that we are able to display all the transformed geometry we made in each iteration all together. If we compare our node group array with the built-in modifier array, we see that this doesn't match. Well, this is not relativity transformation we're doing. Now let's calculate the relative transformation. We can achieve that by finding out how big the geometry is by using the bounding box node, and then subtract the max from min, multiply the result with our factor and scale the result by -1 because we made a useless move subtracting the max from the min instead of subtracting the min from max. Now if we connect the result, we can see that we have successfully made a relative offset. We are on constant offset now. Let's first make the constant offset boolean option and an input socket. Set the type to boolean, rename it to constant offset and add another input socket, set it to vector and rename it to distance. Use a switch node to make the enabling and disabling option possible. Then add the value to the value going to the translate node. We have achieved constant offset. Let's go to object offset. Create the boolean option. Add an object info node to create an option where we can select any object as a reference for our array. We need 3 nodes to enable or disable the vector values from the object info node. we are on the merge option. Add the option for disabling and enabling the merge functionality. Add a realize instance node because we want a real geometry on which the merge by distance node will operate. Add a switch node to pass through or bypass the merge node. Now I'll just sort things out. Now I'll just test the node we made. Get ready for the bevel node in the next video.